properly?
That looks great.
All right, so I'm Roman Battisti. We're working on the passive acoustics, which we're currently calling World Acoustics Search. The other contributors are Alex Douglas, Anthony Lukach, Carla Peterson, and Maria Kuruvilla. Assuming I pronounced everyone's names correctly. I apologize. I should check last names before I start presenting. And then Wu-Jung Lee was our mentor for this. So the general problem statement, so we wanted an easy and extensible way to find acoustic data. Our initial thoughts were to filter by inputs such as time range, GPS range. We're also looking later at maybe depth ranges, frequency ranges, or sampling rate, and then return the metadata information. And then possibly return dataset URLs. There's been discussion on this, so it may or may not be a future goal. To limit our problem, we worked with 3 online databases to start. So NCEI, OOI, and then ONC, or the Ocean Networks Canada. So all of these have website APIs. However, OOI also has a raw data server, which we had to work with. So progress on this. So we built out a user interface, and then for each database, we can make some API calls for the data. We aren't quite at the point of connecting the user interface with the API calls. So just here we have an example mockup. So for example, you would call the World Acoustics Finder. You can specify array of parameters. For example, here we have min time and max time. You can also do GPS coordinates, which I'll show in the next example, and you can do a combination of these. We've also specified you can do regions. So for example, we're planning on having terrestrial, marine, and possibly freshwater, if that's distinguished from terrestrial. And so you could simply specify a region, and then you just find your acoustic sensors, and then the output would be the sensor information. As a second example, you could call up, for example, latitude and longitude, and then give a radius. We also do a min-max latitude and longitude if you prefer that. And then you can simply do an call to find acoustic sensors, but this will return all freshwater, marine, and terrestrial data. So we also built out an API just to do simple calls if you want specific types of data if you haven't specified previously. So for example, you just find freshwater or find marine or find terrestrial acoustics. Some challenges, of course, each website API is unique. For example, for the NCEI data, not all the data is available via the API. So you need to pull the metadata and create a searchable catalog. Several of them also have trouble. You can't do searches across their database for certain parameters. So not all of them take a GPS coordinate. To do a search, you have to pull the data for example, a time range and then filter afterward. There were several successes. We used a few new databases, and we've gotten most, if not all, the APIs to work for us, either mostly getting into CSVs or into Jupyter notebooks that will later be turned into functions or classes and then connected to the user interface. Then finally, some continued work. We, of course, want to finish the API calls, hopefully be able to filter by depth, frequency, and sample rate, and then of course expand the catalog with additional databases. For future use and for people who would want to work with this code, we want to make the code more extensible as well. And that's all I have.
Brilliant.